going to look at systems of inequalities. Now, we have graphed inequalities before just with one. This time a system is more than one. So we're going to put two different inequalities on the same graph. Okay, so let's look at example one. What are the solutions to this system of linear inequalities? So first we're going to graph. We're going to make sure that that line is in slope-intercept form, and then we're going to graph that first. So I have 0, and then I'm going to go up 3, right? My slope is 3 over 1. So I'm going to go up to 3 to the right 1. So I go up 1, 2, 3 to the right 1. I keep going. Same thing in the other direction. Okay, now as a reminder, greater than or less than is a dashed line, and greater than or equal to or less than or equal to is a solid line. So this is a dashed line, so I'm going to just dash my way through it, arrows on the end. Now again, greater than or equal to is we're going to shade above, and less than or equal to we're going to shade below. Okay, so this is a less than, so we're going to shade below that line, so that would be here. Okay, let's look at the next line. So I'm going to bring my x to the other side, and I have negative 2y is greater than negative x minus 6. Divide everything by negative 2. I divide it by a negative number, so I have to change the direction of that sign, and that becomes positive 1/2 x plus 3. So my y-intercept is 3. My slope is positive 1 over 2, so I'm going to go up 1 to the right 2, up 1 to the right 2, same thing on the other direction. And then this time, again, it's also a dashed line, so I'll dash that through. So I'm going to shade below, right? Less than is below. So that shade would be here. Okay, now what do we do from here? I'm looking for the overlapping region. That is where all the solutions are. So the overlapping region in this particular graph is all in this area. So the solution is all those points in that shaded overlapping region. Okay. All right, let's look at another one. So do the same thing. First, we're going to graph. I'm starting at 2, and I'm going to go up 1 to the right 3, up 1 to the right 3. Same thing in the other direction. And I'm going to dash it. Now this time, I'm going to shade above, right? That's greater than. So I'm going to shade above. And now I'm going to look at my next one. Now there's no y here. So this is going to be a vux, right, which is a vertical line through negative 3. So when I go to negative 3, that's a solid line, right, because we have greater than or equal to. So I'm going to do a solid line through x is equal to negative 3. Greater than or equal to. All the numbers that are greater than or equal to negative 3 are on the right-hand side, right? 3 or 4 or 7 or negative 2 are all on the right-hand side of that line. So again, the overlapping region here is everything that has both the blue and the green. So it's everything there. Okay, so our region, our overlapping region is where the solutions are. Now this is a solid line, so it would include points on that line, but the dashed line is not including those points on the line. All the points up to the line, but not on the line. Okay, let's take a look at the next one. Again, I have to get this in slope-intercept form. So I'm going to bring that negative 3x to the other side. I divide both sides by 4. So I have y is greater than 3/4 x. All right, so my y-intercept is at 0. My slope is positive 3 over 4. So I'm going to go up 3, 1, 2, 3. To the right, 1, 2, 3, 4. I'll do one in the other direction. 1, 2, 3. 1, 2, 3, 4. Again, that's greater than, so that's dashed and shaded above. Okay, let's look at the other line. Again, I'm going to do the same thing. Bring that 3x to the other side. Divide everything by negative 4. Now remember, because I divided by a negative number, I'm going to change the direction of the sign. And I have 3/4 x minus 2. Now, right away, I notice that my slopes are the same. So I know these lines are going to be parallel. So in this time, I'm going to start at my negative 2. And I'm going to go up 1, 2, 3 to the right, 1, 2, 3, 4. And I go down 1, 2, 3 to the left, 1, 2, 3, 4. Okay, this time I have a saw line, so I'm going to draw my saw line, right? So we have less than or equal to. So it's saw line, and I'm going to shade it below. Now this one's a little different. Because they're parallel lines, the lines are not going to intersect at all. And when I shaded, there is no overlapping region. So remember that in an inequality, in a system of inequalities, that the solution is where the shading overlaps. Because I don't have anything here, I have no solution. There is no point that gives you a true statement for both inequalities. So my answer is no solution. And you have to make sure you remember to write that, not just the graph. You have to identify the fact that nothing overlaps. All right, let's take a look at the next one. Now this time, instead of graphing it, it says to rate the system. Okay, so let's take a look at the first one. I notice that I'm counting by one, so I'm okay. If I look at this dashed line, I'm starting at 3, right? So that's my y-intercept. I'm going to put my y here. I notice that my shading is below, right? That's that green part is shaded below. And I notice it's a dash, so it's going to go to less than there. Now I have to find the slope of the line. So there's a point that goes through the corner of a box. Here's my next one. So I'm going up 2 to the right 1. So when I go up 2 to the right 1, my slope is 2 over 1 or 2. So just kind of slide that in there. And I have y is less than 2x plus 3. And that's the inequality of the first equation, the first inequality statement, okay? Let's look at the next one. Now, looking at the next inequality, I'm going to first look at the line. My y-intercept is at 4, positive 4. I notice that is solid line, and I'm shading above, right? This overlapping region is above. So solid and above is greater than or equal to. Again, I have to find the slope. So I have this point that goes through the corner of the box, and so does this one. So I'm going down 1 to the right 1. So down 1 to the right 1 gives me a slope of -1. So I have negative x. So again, this is the system of the inequalities. You need both statements there. All right, let's look at the next one. Now this one is a little trickier because I'm counting by 2's, right? When I look at my x and my y-axis, everything is counting by 2. So I have to keep that in mind. Okay, let's look at number 1. My y-intercept is right here. That looks like that's -2. Now I have a solid line and I shaded below. So solid and below is less than or equal to. Let's take a look at my slope. Again, I'm going up 1 to the right 1. Now, it doesn't really matter how you look at this because I'm going up 1 to the right 1. Or because each block is 2, because the x and y axis have the same units, I could also say up 2 to the right 2. But regardless, I would get 1 over 1. That would simplify also to 1. So my slope is 1. So I'm going to put 1x in there. So y is less than or equal to x minus 2. All right, let's do the same thing with the second line, this red line. Again, my y-intercept is there. That looks like it's +2. And it looks like I'm shading above and I'm solid. So above and a solid is greater than or equal to. Now I need to find the slope. So I'm going to go here. And again, if I count by ones, I go up 1, 2, 3. So I'm going to go up 3 to the right 1. Or if you want to count by 2's, I went up 6 to the right 2. Regardless, my slope is a +3. So I'm going to slide in a 3x there. Okay. All right, let's take a look at our last problem for today. It is a word problem. Now, I have set things up to save some time with the video, but if at any point you want to stop or try it on your own or rewind the video, you are always welcome. All right, let's see what it says. A family in consumer sciences class is making pillows and blankets to donate to a local shelter. The class has 40 yards of fabric to use. Pillows require 1.25 yards of fabric and they take 1 hour. So if you want to make a pillow, it's going to need 1.25 yards of fabric and it's going to take an hour to make. Blankets, they need a little bit more fabric, 4 yards, and it's going to take longer as well, 2.5 hours to make. So they have 28 hours of class time left for the semester. Determine the number of pillows and blankets the class can make for the shelter. So what I did first, which is what I've done a lot in word problems, is I just pulled out the important information. Everything we talked about. You have 40 yards of fabric to use. You have 28 hours left. A pillow is 1.25 yards, takes an hour. Blankets are 4 yards and 2.5 hours. Okay, so I noticed they already gave us the graph. So I noticed that blankets made is on the x-axis. So I marked that there. And same thing, pillows are on the y-axis. All right, so let's take a look first at our inequalities. So fabric. If I'm talking about fabric, pillows take 1.25 yards. Blankets are 4 yards. And I only have up to 40 yards to use. I don't have to use all of it, but that's the most I can use. Time, same thing. I know I only have 28 hours left. A pillow is 1 hour, so you can make that 1p if you want. Blankets is 2.5 hours. Now, I know if I'm going to graph this, I need to put this in slope-intercept form. So let's first talk about the fabric. So I ended up putting it in slope-intercept form. 32 is going to be my y-intercept. Now, if I look at this, the graph, it looks like everything is by threes. So 32 would be right about here, right? This is going to be 33. So I'm going to say right about here. Now, the tricky part about this one is my slope is negative 3.2. That's kind of a tricky number to work with. So what I did is I went back, and I'm just going to rewrite it up there. I know that my y-intercept is going to be 32, right? We found that down here. Now, to find my x-intercept would mean my p-value is going to be 0. Now, we've done this before using x and y intercepts. So if I make that p-value equal to 0, that would be a 0 there, plus 4b is less than or equal to 40. So I know b is less than or equal to 10, right? Now, again, when I graph the line itself, I actually need that to be equal, right? So what I'm going to do is I know my x-axis or my b value is going to be 10. And then at this point, just to make it a little easier, instead of counting rise over run, I'm just going to connect those 2 points, the x-axis and the y-axis. Now, again, it's less than or equal to, so it's a solid line. So I'm going to draw my solid line. And I know that the shading is below. Okay, I'm going to do the same thing with time. I put it in slope intercept here. Let's change colors. And I know that I have 28 as my y-intercept. So it's going to go right about here. Okay, same thing. If I want to find out what b is, I'm going to make p is equal to 0. And then I have 2.5b less than or equal to 28. So in the end, if I divide both sides by 2.5b, I know b is less than or equal to 11.2, or I know the b value is going to be 11.2. So I'm going to go just above it, 11.2. Now I notice my x-axis is marked by 1, so I'm going to be right above here. And again, this is where it's a good idea to use a ruler because it's going to be really tight. So again, I know I have a solid line, so I'm going to draw a solid line here. And here is my shading because I know it's less than or equal to, which is below. So my overlapping region on this one, it's a little tricky because this one's super tight. So you have to be careful here. It's going to be everything in here. Okay. So this really, all the shaded region is a solution to this system of inequalities, which also tells you how many blankets they can make. So the last part says, find a solution and describe its meaning. So for instance, I noticed that 4, 6, that's in my shaded region. So if I take that as a solution, my 4, remember that's my x-axis, that's b, and my 6 is my p. So that means I can make, the class can make 4 blankets and 6 pillows. Okay? Thanks so much for stopping by today. You have a great day.